So this time I will show you how to use SnapPy outside of Sage, and I assume that you have installed Magma, and we use Magma as engine to solve the ptolemy variety. So I'm starting with just a manifold, this time the complement of a 5-2 knot to make it a little bit more interesting. And then I can just ask for the ptolemy variety as you have seen before. So let's do it for SL2 in the non-trivial abstraction class. And if I just call p compute solutions, it will actually create the ptolemy variety, write it out into a file, give that file to Magma, ask Magma to solve the compute the Gribner Bayesian primary decomposition of that file, and then parse that solution and produce a solutions object like we had before. So if I do this, blop, that was pretty quick. And now let's save it, and then we have the solution, so you can do the usual things I showed you in the previous videos with the solution, like compute the volume, for example. This is implemented in Pari, so I can, even though I'm not in Sage, I can actually set, for example, the precision really high, and then get the volume to arbitrary precision. I want to show you a little bit on what is happening under the hood when you do this. So by default, the engine it's using is Magma, but you can explicitly specify that you want to use Magma. And then you can specify verbose, and that will actually print out some additional information when it's starting Magma, so you can understand what's going on. So we see that SnapPy wrote to a temporary file, and then it called Magma to read from a temporary file and write into a different file, and then it was taking that output file and parsed it and gave a solution. You see that Magma was started with ulimit, so that it would not like just eat up all your memory and swap your machine and crash it. And you can actually change that memory limit. For example, let's say you want to allow Magma to use a full gigabyte. Good. So we can look into that temporary file. And there's the Magma file. So it produces this Magma file that constructs a polynomial ring, constructs the ideal, and then it has this section here, which is used for Python later to actually take the Magma solution and convert it into a solution object. And then finally here we have the command for primary decomposition, and it says print out the primary decomposition. I could have there are methods to actually do this manual. So I can, the ptolemy variety has a method called toMagma, and if I call it, it will actually produce you the Magma output for this ptolemy variety. And I can even write it to a file. So let's write it to this thing, and then I can actually go there and explicitly start up Magma, have Magma's result write into a different file. Good. And now I can take that file here and actually parse it in SnapPy and give you a solution. And I will show that to you in the next tutorial.